Dear students, in the last module, we have learned about different protections and cures for network attacks which could happen in our computer system. However, there could be some things, for example, the attacker is not wanting to destroy your computer system. It is basically trying to hack the content. So for that, we need encryption. So we learned about how to secure computer system, but one of the main threat is to gain access to your data, because your data could be very important and secure for yourself. For example, your credit card number or some of your documents which you do not want to share publicly. So one solution could be that you are logged in onto your computer using a password. That is a perfect solution. However, this solution cannot be applied when the data is traveling on the internet and going from one place to another place. So in between, there could be some hackers which can deceive and which can acquire your data on the internet. So what we can do? We can have different strategies. One of the strategies is having secure version of HTTP. So your websites, as we learned in one of the previous modules, could have secure versions of HTTP known as HTTPS. And the backbone of HTTPS is Secure Sockets Layer, which was developed by Netscape to provide secure transmission between client and the server. So this is one of the way. And there could be some other ways. For example, if you are sending your data to some other computer, you can encrypt that data, which means the message which you are going to send from one place to another place, that message is not going in the same fashion. For example, you want to send Apple. So this is a data, and you can translate Apple as a ABC XYZ. So this should be understood by the receiver that you are saying Apple. So you need to define some codes that how you are going to encrypt your data, which is when transferred on the internet is not the real data, is not understood by the hackers, but your receiver end could easily understand what you are sending. So one of the way is using public key encryption. We will learn in the next slide that it is a fascinating strategy, and even having knowledge of how messages were encrypted, it does not allow the users to understand that what is actually the message. So for example, let's have a practical example of it. For example, Alice and Carol want to communicate with Bob. So both have their public keys with which they are going to encrypt the messages, and Bob will understand that message with its own private key. So if there is a scenario that Alice wants to send some message over here, and that message is hacked by Carol, and it also has a public key, which means that this message could be understood by Carol. However, it will not happen because this message cannot be decrypted using the public key. It can be decrypted only by Bob using its own private key, which means that this message can only be understood by the receiver only. So Carol cannot decrypt Alice's message even though she knows how Alice encrypted it. So this is one of the strategy of using public key encryption. So such kind of public key encryption could have some problems as well. For example, you must know that the public key you are using is the right one. So for example, if you are using the wrong public key, then that message could not be understood by the receiver, and that could be understood by the hacker if you are using the public key provided by the hacker in some way to you. So using a wrong public key make your message waste for the destination and useful for hackers. So what is the solution of such a problem? We could have certificate authorities. So it servers provide reliable public key information to their clients in packages known as certificates. And a certificate is a package containing a party's name and the public key of that party, so that the message is properly encrypted using the public key of that party for which you are going to encrypt your message. Because on an internet or on a network, you are going to encrypt messages for different parties. There is another important concept known as digital signature. So in some of the public key encryption systems, the role of encryption and decryption can be reversed. So this means the message is going to be encrypted using private key. So encryption with a private key. The holder of the private key can produce a bit pattern called the digital signature, and the message is revealed to be authentic because this message cannot be produced by anyone who does not have the private key. So if we summarize today's module, we have learned about HTTPS, public and private key mechanisms, certificate authorities, and digital signatures.